Have you ever wondered what it would be like to use smart contracts with Satoshi-style UTXO-based blockchains like Bitcoin, Peercoin, or Litecoin? The developers at Peercoin, pioneers of the original proof-of-stake blockchain, have been working on a solution that makes this possible. Their new technology stack enables private smart contracts that execute off-chain, with final settlement taking place on-chain. This is where discrete log contracts, DLCs, oracles, and a novel off-chain consensus technology called Roast step in. By combining these powerful tools, real-world information can be trust minimized and fed into the blockchain, allowing for secure, private, and efficient contract execution. Let's dive into how it all comes together. Discrete log contracts, DLCs, are a type of smart contract that enable two or more parties to form a trust-minimized agreement about a real-world event, whether it's the final score of a football match or the price of an asset on a certain date. One key feature is that only the parties involved know the exact details of the contract. However, since blockchains cannot directly observe off-chain events, an external third party is needed to verify what actually happened. This party is called the oracle. By supplying the correct information, like the match winner or final price, the oracle allows the DLC to resolve according to its terms. The role of the oracle. Since blockchains have no built-in awareness of external events, they verify only what happens within their own network. Oracles bridge the gap between the real world and the blockchain by supplying validated data, like Team A won, or the final score was 2-1. For a DLC, each party wagers on an outcome, and the oracle's signed statement confirms what really happened. What's special is that the oracle doesn't hold anyone's money. It just provides a signed message. If Alice's team wins, she uses the oracle's signature to unlock the funds in the DLC. If Bob's team wins, Bob does the same. The oracle itself doesn't need to know who's betting or how much. It only needs to publish a verifiable result. An oracle can post its signed outcomes anywhere: a forum, Discord, a social network, whatever works. Anyone who trusts that oracle can reference its public key to verify these outcomes. Since the oracle's signature is universally recognizable, multiple DLCs can rely on that same piece of data without any extra work for the oracle. A distributed oracle. Imagine a close-knit group of 12 friends who are die-hard football enthusiasts. They spend their spare time watching football matches, reading in-depth analysis, tracking player stats, and bantering about every goal, card, and victory. For fun and to earn a little profit, they've decided to set up a shared service that publishes match results and key in-game events. Organized through a casual WhatsApp group, they rely on human-to-human consensus to finalize each piece of information before broadcasting it to the world. From an outsider's perspective, this oracle looks like a single entity identified by one public key on the blockchain. In reality, behind that single key is a lively 12-person swarm using a technology called Roast to combine their partial signatures into a single Schnorr signature. A minimum threshold, for example, 9 of the 12, must agree on the data before the signature is valid. Because everything is internally logged, they can easily see who participated, who skipped, or who repeatedly disagrees in an effort to sabotage the process. If someone becomes disruptive, they can exclude that person from their setup. Ultimately, the service never deals directly with bettors or tracks specific wagers. It simply provides signed, verified facts for anyone who needs them. This approach keeps the collective's inner workings private and ensures that all that's visible on the outside is a trustworthy source of football data, powered by 12 passionate fans. Proposals and validation. When a match event happens, like a goal or a final whistle, any Oracle member can propose a message to be signed. The group checks reliable sources, live broadcasts, official score trackers, etc., and decides if the data is correct. If enough members sign off, the swarm produces a single signature. To outside observers, it's just one message from the Oracle. Inside, it's distributed consensus among the 12 contributors. Publishing the data. Once the group signs the message, it's posted to a public feed. People who have access to this feed receive real-time stats, scores, red cards, corner counts, or even the man of the match. Verifying that data is straightforward. If you know the Oracle's public key, you can confirm the signature. Any tampered or fake results simply won't verify. Monetizing the Oracle. Can the Oracle be a commercial venture? What if the group wants to make a few coins along the way? The most reasonable way to do this seems to be charging subscribers for access to signed data. They might accept on-chain payments, payment channel payments, or any other system. The Oracle doesn't need to know players' identity. It only cares that you paid. Practical workflow. Publishing the schedule. Before the football league begins, the Oracle posts a schedule of fixtures, dates, teams, and any special stats they plan to cover. Each match has a unique identifier, so bettors know exactly which event the Oracle will sign. Creating DLCs. With the schedule published, Bob and Alice can craft a discrete log contract. For example, Alice bets on Team A, Bob on Team B. They reference the Oracle's match identifier, lock up funds, and wait for the result. The Oracle has no idea this specific bet exists. It simply continues to provide data for everyone. Match day. During the match, key events, like goals or red cards, may trigger updates. Multiple Oracle members verify the facts in real time. If enough of them agree, the system issues a signature confirming the event. Asynchronous coordination. Because the group uses a threshold system, they don't all need to be online at once. As soon as enough signers confirm the data, the signature is valid. If some are asleep or offline, the rest can still produce a result. Publishing final result. After full time, the Oracle posts the official final score and any other stats in a single signed message. That's all DLC participants need for settlement. Claiming winnings. If Alice's team won, she obtains the Oracle's signature for Team A wins and uses it to unlock the contract's funds. Because the blockchain validates that signature, Bob can't dispute it. He lost the bet, and that's the end of the story. The conclusion. Discrete log contracts powered by oracles let people trust the outcome of real-world events on the blockchain without relying on a single third-party custodian. The Oracle example shows how a distributed group can act as a single, reliable source of sports data. They publish scores, stats, and final results in a form that anyone can verify, while remaining completely unaware of who's using it and why. This combination of privacy, security, and decentralization opens up endless possibilities for betting markets, asset hedging, and beyond.